Dear students, now I am going to teach you the topic transistor biasing. Okay. What is meant by biasing? Applying external DC voltage to any electronics devices known as biasing. Here bipolar junction transistor. For the bipolar junction transistor, external DC voltage is applied. Okay. In transistor biasing, there are three types. They are base bias, collector to base bias, voltage divider bias. Let us see one by one. Base bias, it is otherwise called as fixed bias. Okay, so in the circuit, see, this is the bipolar junction transistor, right? So the terminals collector, base and emitter, right? So VC is the voltage between collector and emitter, VB is the voltage between base and emitter, right? IB is the base current, then RB is the base resistance, RC is the collector resistance. Okay, here base current IB is constant determined by VCC and RB. Okay, so in fixed bias, so it is a fixed bias, is it not? So here IB base current is constant or fixed, right, which is determined by VCC and RB, right? And voltage drop across RB is VCC minus VBE, right? And the base current IB is equal to VCC minus VBE divided by RB. Based on the Ohm's law, V is equal to IR. From that, what is I? I equal to voltage divided by resistance. Here the voltage is VCC minus VBE, right? Divided by the resistance is RB, right? So this is the base current which is fixed or constant in the case of base bias or fixed bias, right? And collector current IC is equal to HFE into IB. Okay, and HF is the gain of the transistor. See, the next one is collector to base bias, right? Here the base resistance RB is connected between collector and base, right? So this is the collector terminal, this is the base terminal. Between these two terminals, the base resistance RB is connected. Okay, it improves the stability for HFE changes, right? See, in case of fixed bias, the stability is somewhat poor, right? So when compared to fixed bias, so collector to base bias improve the stability of the transistor. Okay, and here, so VC is the voltage between collector and emitter, which is equal to VBE plus IBRB. Okay, we just take this is equation number 1. Then IB is equal to, from this, what is IB? IB is equal, you just keep this IB into RB one side and remaining, you just bring this left side. So VC minus VBE, and from that if you are finding IB, VC minus VBE divided by RB. Then VC is equal to VCC minus RC into IC plus IB. You just take, this is equation number 2. Right, so equation number 1 and 2, which is for VC, right? We can equate these two. So what will you get? VBE plus IB RB is equal to VCC minus RC into IB plus RC. IB, what is it? Minus RC into IC plus IB. Then see, IC is equal to HFE into IB. Is it not? You just substitute this IC here. So what will you get? VB plus IB RB plus is equal to VCC minus RC into, instead of IC you have to substitute HFE into IB. So HFE into IB plus IB. Then you just bring IB outside here. So minus RC into IB, HFE plus 1 you are getting. Okay. Next, the next step, you just bring this negative term to the left side and you just bring this VBE to the right side. So what will you get? IB RB plus RC into IB into 1 plus HFE, which is equal to VCC minus VBE. Okay. Then from these two terms IB can take outside, then remaining term will be there. From that you can find IB. So IB is equal to VCC minus VBE divided by that term, right? So RB plus RC into 1 plus HFE. This is the base current, right? Thing is, here in collector to base bias, so stability is somewhat improved, and the resistance, base resistance is connected between the collector to base. Okay. Okay, and next one is voltage divider bias. Okay, so in voltage divider bias, voltage divider circuit will provide the biasing for the transistor. Here the voltage divider is R1 R2. Okay, and it is the most stable circuit. Okay, and here the base voltage VB is equal to VCC. You just see. So this is the base voltage VB. Okay, and which is equal to VR2. Right? By applying voltage divider rule, you can find VB. VB is equal to total voltage VCC into same branch resistance R2 divided by R1 plus R2. Okay, so we just applied voltage division rule. Okay, then emitter voltage VE is equal to VB minus VBE. This emitter voltage is equal to VB minus VBE. Okay, next IE is equal to VE divided by RE. You just substitute VE here, so VB minus VBE divided by RE. Then collector voltage, transistor collector voltage VCC is equal to VCC minus ICRC. VCC minus ICRC. Okay. Then collector emitter voltage is VCE is equal to VC minus VE. Okay. So that's all about the transistor biasing. Thank you.